Hello, myself Dr. Shaila Dinkar Apte, and let us continue with this series of videos. Last time we have seen the properties of CT and DT signals. Now we continue with properties of CT and DT systems. Now there are different objectives that we will consider in this particular lecture. We'll consider the properties of the systems. Under that we'll consider linearity property, time invariance property, superposition property, causality, memory, and then we'll see what are LTI systems. LTI means linear time invariant system. So consider any continuous time or discrete time system. It will be considered as linear if it obeys two important properties. What are these two important properties? One is homogeneity and additivity. In simple words, homogeneity means if the input is scaled by a factor of k, and if the output is also scaled by the factor of k, we say that it is homogeneous. And additivity means if I add the two inputs, then the corresponding output will be the added output for corresponding for the input 1 and corresponding to output 2. So that is called as additivity property, simple to understand. So in case of homogeneity, let us say that x1 is scaled by a factor of k, the output is also scaled by the same factor. Similarly, for DT system also, it will be scaled by the same factor. That is called as homogeneity. And additivity means if the two inputs x1t and x2t are added and given as input to the system, the output is y1t plus y2t, where y1t is the output for x1t and y2t is the output for x2t. So the corresponding outputs, if they directly get added, we say that it obeys additivity property. Then we have the superposition property. So we say that the superposition holds good when it is additive but with different scale factors. So in this case A and B both are equal to 1, it gives you additive property. But if x1 is scaled by a factor of A and x2 is scaled by the factor of B, and if this is given as input to the system, the output will also be correspondingly scaled by a factor of A for y1 and scaled by the factor of B for y2. So same thing is holding good for continuous time as well as discrete time systems. Consider this example here. Y is equal to xn plus 5. So in this case the system has a bias. This particular system can be represented by this straight line. This is a transfer graph. Transfer graph means xn can be directly transformed into the yn using this directly the graph. This is called as a transfer curve. So in this case this transfer curve has a bias of 5, and because of that, see, if x1 is multiplied by the factor of 5, the output is not directly multiplied by 5 because it has some bias. So you can see that if xn is equal to 0, the output is 5. If xn is equal to 1, the output is some y1. But in that case also this 5 is getting added. So it is not getting doubled or anything. If x1 is doubled, y is also doubled. This case is not happening here. So this is not homogeneous. Similarly, in case of additivity, what will happen? A1 x1n plus 5 plus b x2n plus 5. So it will just get added, and but it is not equal to a1 x1n plus b x2n plus 5. So this will be added by 10. So it is not obeying the additive property as well. So in this case the system is not linear, but you can say it is incrementally linear. That means if we avoid this bias and if we plot delta x divided by delta y, it will be linear. So it is called as incrementally linear. Now consider the system represented by yn is equal to 0. So for all xn it will be 0. So if xn is multiplied by 0, x1 is multiplied by k, the output is also multiplied by k because the output is 0. So in this case it obeys the linearity because it is passing through the origin. So simple check is plot a graph, find out whether the linear graph is obtained, and if this linear graph passes through the origin, the system will be said to be linear. As we already know, cosine and sine functions are non-linear. So if corresponding yn is represented as cos of xn, then the system will be automatically non-linear. Now this is one more example. This is for the discrete time system, real continuous time systems now. Yt is equal to xt plus 2. So again, this is similar. It is having a bias and it is not giving you the homogeneity property. Also, the additivity property will be not holding good. So in this case, the system is nonlinear. But in this case, it will be again incrementally linear if you avoid this bias. Now consider the system yt is equal to 0.1 into xt. Now if in this case xt is multiplied by the factor of k, the corresponding yt will also be multiplied by the factor k. Similarly, it will obey the superposition principal, superposition property. So the graph is a straight line and it passes through the origin, and you can see that the system is linear. Now what is the physical significance of this linearity property? If the system is linear, the transfer graph, that is the output versus input graph, will be a straight line and it will pass through the origin. If the system is linear, for any input signal, we can calculate the output by just decomposing the input signal into number of parts and then finding out the corresponding outputs and then adding up the two. So when I am calculating the output for x1, I will consider that x2 is 0. When I am calculating the output for x2, I will consider x1 is 0. And then I will superimpose the outputs. That is why it is called as superposition principle, superposition property. So consider continuous time systems that obey the superposition. Let us say yt is equal to integration minus infinity to t by 4 x tau t tau. So a1 y1 t plus a y1 t plus b y2 t will be what? A into x1 tau d tau plus b integration x2 tau d tau. So which is equal to minus infinity to t by 4. I can take this a and b inside. So a x1 tau plus b x2 tau d tau. So but what is a x1 tau plus b x2 tau? This is your input, right? So for the scaled and added inputs, you just get the scaled and added outputs. In this case, the superposition holds good and the system is linear. Now in this case, yt is equal to d dt of xt. So even though there is integral involved, the system is linear. Here yt is d dt of xt. This is the differentiation that is involved. Now if I take a x1t and b x2t, and if I take d dt of this, I can decompose and say a into d dt of x1 plus b into d dt of x2t, which is same as a y1t plus b y2t. So here again superposition is holding good, so the system will be linear. Similarly, for discrete time systems, suppose you consider yn is equal to summation minus infinity to n x of k plus 1. So k is varying between minus infinity to n to generate yn. So a into x1 plus b into x2, how it will generate the output? It will generate the output as a x1 k plus 1 plus b x2 k plus 1. So again I can write it as equal to a y1 n plus b y2 n. So it obeys superposition principle, as you can see. Similarly for this, xn summation infinity to infinity delta n minus 3k. What is delta n minus 3k? It is existing for n is equal to 3k. So only for n equal to 3k this is existing, and yn will be equal to x of 3k, right? Now if I put x1, a x1 and b x2, then correspondingly it will also generate the same output. That means this summation term will be there as the just the common term, so I can take it out and I can say that it is ax1 plus bx2n. So this is again obeying the superposition principle, and then this system will also be a linear system. Now there is another property called as time invariance or shift invariance. What is this property? So suppose, let us say that I know the output for a system for the input as xn. Now if I shift this xn by the factor of by some k samples, does the output also shift by the same samples? If it is so, then I will say that it is time invariant. So yt or yn is the output of some input xt and xn respectively for analog and digital systems. Then for a shift invariant system, if the input is translated by k units of time, and in this case k samples here, then the output will also be translated by the same amount. Then we'll say that there is no change in the nature of the output, it is just getting shifted. Then it is called as time or shift invariance. Now what is physical significance of shift invariance? If the system is time or shift invariant, then the output of the system for any shifted input can be easily calculated by introducing the same amount of shift in the output. So already if you know the output for xn, I can also calculate the output for x of n minus k. It will be same as y of n minus k. So introduce the same amount of shift in the output and you will get the output for the shifted input. Now consider the shift invariant system. For consider the example yt is equal to x of 1. Now is it shift invariant? If I shift x by k amount, let us say I take x of t minus k, what will be y of t minus k? Y of t minus k will be same as x1. So it is not dealing with the value of t at all. So in this case it is some constant, x1 means it is some constant. So the system is non-linear and it is also shift invariant. Y of t minus k is not equal to x of t minus k, but it is directly a constant. Now consider yt is equal to x of t whole square. Now if the input is shifted by k units, what will happen? Input will be x of t minus k. What will be the output? It will be x of t minus k will be equal to x of t minus k the whole square. So output will also be shifted by a factor of k. So in this case the system is shift invariant, but it is non-linear as we know because it is containing the square. Okay. Now consider yt is equal to t by 5. In this case, if I use x of t minus k as input, what will be the output? Output will be x of t minus k by 5. So it is same as y of t minus k. So in this case, again the system is time invariant or shift invariant. Now consider dt systems. Now y is equal to sine of xn. If input is x of n minus k, the output will be y of n minus k, sine of x n minus k. So the system is shift invariant even though it is nonlinear. If I consider yn as 3xn into un, if the input is shifted by k units, the output will be 3 into x of n minus k into un, which is not equal to 3 of x of n minus k into u of n minus k. So the system is not shift invariant in this case because this un is not getting shifted, it remains the same. Actually xn is just shifted by k units. Alright, so this is not shift invariant in this case. Now consider yn is equal to log to the base 10 mod of xn. Now what will be y of n minus k? It is log to the base 10 mod of x of n minus k. So this is shift invariant. Now in this case this is yn is equal to xn summation n varying from minus infinity to infinity delta n minus 3k. So y of n minus k1 will be equal to x of n minus k1 into summation of this delta but this is not same as x of n minus k and summation delta n minus 3k minus k1, right? So in this case, this delta is not shifted. That is why this is not shift invariant. Now consider LTI systems. What is LTI? Linear time invariant system. Linear time invariant system is one which is linear and it is also shift invariant. It is linear means it obeys homogeneity property, linearity property, superposition property, and also it is shift invariant. If the system is linear time invariant, one can characterize the system in terms of its impulse response. And in that case, the principle of superposition holds good, can be applied. So what is the impulse response? Impulse response is the response of the input to any small impulse at any particular time t. So if the system is LTI system, I can characterize the system. I can say that this is the property of the system, that it has impulse response as so and so. The output of the system to a shifted delta function is just the shifted impulse response. The computation of the output for any input signal is greatly simplified. Let us consider one example here. And now this is a discrete time signal. N is equal at n equal to 0, the output is 1, n equal to 1, this is 2, n is equal to 2, this is 3, right? So how I define this xn? Xn is delta n plus 2 into delta n minus 1 plus 3 into delta n minus 2. So what is this xn? Xn is the summation of scaled and shifted delta functions. Now what will be yn, corresponding output? If I specify the yn as some impulse response of the system, that means the response to delta n is known. What will be the response to delta n minus 1? It will be the shifted version by a factor, by the time unit of 1. And what will be the response to delta n minus 2? It will again be the shifted version by 2 samples, right? So I can just calculate the response to delta n, which is impulse response, delta n minus 1, which is shifted by 1 unit, delta n minus 2, the output is shifted by 2 units, and if I scale it by appropriate factors and add up, I will get the output of the system for xn. So the output calculation becomes very simple, because I can decompose the input signal into scaled and shifted delta functions. And once I know the impulse response, I can calculate the output for any input signal. So this computation becomes very simple. Let's consider what is causality property. Our system, our human being body is causal because we study from the past. So we go on learning. As we grow up, we go on learning. So we learn from the past. But our output, current output, does not depend on the future inputs. Our output depends on the current and previous inputs, or the previous outputs also it can depend. But it will never depend on the future inputs. That is called as a causal system. Causal system means implementable system, the system that can be easily implemented. But if it contains some factor as some c1 y of t plus 1, at time t, y of t plus 1 is not known, it is the future output. So in that case, the system becomes non-implementable. I cannot implement it. So a causal system is the implementable system. It depends only on the current and the previous inputs. It may also depend on the previous outputs, but not in any way on the future inputs or the future outputs. Now consider this example. Y of t is integration tau is equal to minus 1 to plus 1, h of tau x of t minus tau d tau. Now consider corresponding tau as equal to minus 1. Now if tau is equal to minus 1, what will happen? I will get h of minus tau and x of t minus tau. tau is minus 1, so it will become x of t plus 1. So the corresponding output depends on the future input. If it depends on the future input, how the system can be causal? It is anti-causal. Now let us consider second example. The yn is equal to summation n is equal to minus 1 to n plus 1 x of k h of n minus k. Now what I will do is I will just expand this equation. So for k is equal to minus 1, I will have x of minus 1, h of n plus 1 plus x of 0, h of 0 and so on up to x of n plus 1, h of minus 1. Now in this case, the current output depends on the future input. So in this case, the system is anti-causal. Now, physical significance of causality. Causal systems are practically realizable, and as I said, they are implementable. The system of a human being is causal, as we always keep on learning from the past inputs and the past outputs also. The causal systems can be implemented in real time because I know the current sample and the previous samples. Now, in case when the system contains the future inputs or future outputs, then it cannot be implemented. That is true. But if I know the future inputs, I can calculate the current outputs and can generate a benchmark system for performance. So if I want to say that what will be the benchmark for this system, I can consider the previous data, I can consider the next data, and I can sit and perform it offline, and then I can generate a benchmark system. So for implementation of the offline systems, we can use non-causal systems. But otherwise, for real-time systems, we'll be considering only the causal systems. Then the memory property. The system is said to have memory or said to be dynamic if its current output depends on the previous, future input or previous and future output signals. So in this case, yt is equal to x of 3 minus t, put t equal to 2. In this case, I will get y2 is equal to x of 1, that is the previous input. So the system has the memory. Here the current output depends on the previous inputs, current input and the next inputs. The system again has the memory, right? Physical significance of memory. If the system contains active element like a capacitor or the inductor, the system memory will extend up to infinity. Such systems are said to be dynamic. The human beings always learn from the past, so our brain system allows us to understand the new concepts because we can have the memory.